Engineering Mechanics Statics Lecture 9. The present lecture will explain about the second part of the subject moment, which is moment of a force about a specified axis. There are two methods, which is scalar analysis and vector analysis. Here are the objective of the present lecture. Student will be able to determine the moment of a force about an axis using scalar analysis and vector analysis. First, let's look at this machine. If we have a machine like this, and then we want to rotate this part, and then this is the thrust that used to rotate this part. So when you apply force here, and this part, or we can say that this is a line of action for F to produce a moment. This line of action is a bit slope from the axis of whether X or Y. Okay, so when this is in a slope condition, about a few degree away from the axis, and then you have force here. So the moment, because it is spin like this, right, it is rotate a bit slope also. So the moment, the direction of moment produced is in the direction of MA. But the thing is, the effect of the rotation produce the direction about an axis of Z. Okay, this thing is going up. Okay, so the moment must be in a MZ direction. So how to calculate the moment about this axis? Okay, for this axis we simply can calculate the length of this line of action with the force, which is MA equal to F multiplied with D. But how about the moment about the axis of Z? So here, how you analyze the moment about an axis. Okay, now let's look at how we calculate or how we analyze the moment about an axis, or in this case we denote as a MZ. There are two ways to analyze the moment in the axis of Y. The first method is a scalar analysis, and the second method is a vector analysis. For scalar analysis using 2D approach, we can simply calculate the MA. First we calculate the moment of this direction, which is MA. Simply we calculate using the normal equation, moment equal to D multiplied with F. Your line of action is about 0.5 meter and your force is 20. So simply multiply it, you will get 10 Newton meter. And then if you want to calculate the axis, the moment about the axis, which is in this case axis of Y, so you may take the shortest distance, which is in this direction. Okay, so when you take the shortest distance, and this is your F, so your MZ, while this in this direction, in this rotation, so it is equal to 6 Newton meter. The line of action is 0.3 meter. force is 20, multiply is equal to 6 Newton meter. So that was the normal method of how you calculate the moment using 2D approach, and this is a scalar analysis, but normally your analysis is not as simple as that, because there are many complicated situations that will need the analysis must be calculated using the 3D approach. So in this case, you may need to use the method of vector analysis. Okay. Using the vector analysis, first you need to find the moment, the actual moment of the system, which is in this case is MA. So when you want to perform the calculation of moment in a 3D approach from the previous lecture, we can use the method of cross product. Remember, the cross product is a multiplication between vector and vector R and vector F. So first you may need to find the MA using the cross product method. And then after you get the MA, so to calculate the MZ about the axis of Y, you can use this formula. The answer of MA that you get, you can perform the operation of dot product with the unit vector of the y-axis, okay, which is uy. So this will produce the answer for moment about an axis of y. Okay. So mz, in this case is mz. So mz is equal to unit vector of at the axis of y, dot product with the moment of A or MA. Okay. So MA is equal to R cos F. So this is equals to you can do like this matrix. So the first line is the unit vector, second line is your line of action or R, and the third line is the line of force. Okay. So please remember that this equation we call it as a triple scalar product. So if in the examination asks you to calculate using the triple scalar product, so you must use this equation. Okay, so this is particularly if you want to calculate the moment about an axis. Okay, so the moment is lie on axis, whether in an x, y or z axis, rather than the actual moment. Maybe it is not in the actual axis. Okay. Okay, now let's do some example here. It's if let's say we are given a machine like in this picture. So a force is applied to the tool to open the gas valve. Okay, this is your valve, so you want to open using the glass here. So this is your force, and then this is your line of action. Supposed to be your moment direction, and this way, right? Because it is rotate a bit slow. Okay, but in this way, the effect of the rotation is in the z-axis. Okay, so the question asks you to find the magnitude of the moment of this force about the z-axis of the value. Okay, find the moment about the z-axis, because the actual rotation is about z-axis. Okay, so we need to use the triple scalar product method, which is mz is equal to unit vector of z-axis dot product with the actual moment. Okay, so and then note that unit vector is equal to 1k. Okay, so please remember this, any unit vector that lies directly on the where the x, y or z axis, the unit vector is simply equal to 1. Okay, if the axis is at the z axis, so the component is in the k component. Okay, if it is in the x axis, so the unit vector is in the I component. Same with if the unit vector lies in the y-axis, the component is in the j component. Okay, so please remember this. Okay, and then the third one is the vector r is the position vector from A to B. Okay, so your r, your line of action, you should take the shortest distance from the point of rotation to the F, which is from A to B. This is your line of action. And then the last one, the force F, is already given in Cartesian vector form. Okay, so you already have your unit vector, which is equal to 1k, and then find the line of action in a vector form, in the vector Cartesian form, or your RAB. The line of action is also RAB, or vector position, is same meaning, which is RAB. So this is I already explained in the previous lecture. So how to find the RAB? So first you need to know the coordinate at A and B, and then after you know each of the coordinates, so subtracts the coordinate, the tip coordinate with the tail coordinate. Okay, which means that you need to subtract the coordinate from B to A. Okay, so find the coordinate of B. It should be 0.25 sine 30 in the x direction, 0.25 cos 30 in the y direction, and then the z is 0.4 meter away from the origin. Okay, minus with coordinate of A should be 0, 0, 0, because it is in the origin. Okay, so you will get the vector form of RAB is equal this one. Okay, and then your vector form of F is already given, you don't need to find. Okay, so you already have three vector here for unit vector, and then for R, and then for F, using this equation of moment about an axis, mz, or triple scalar product. Perform this operation using this matrix. For the first line is for unit vector, for the unit vector, which is 0, 0, 1, because the component is at k. And then the second line is for R, and then the third line for force, and then because the value is only at k components, so you can eliminate this line, and then do the cross multiplication operation 0.125 multiply with 20 minus 0.2165 multiply with negative 60. So this is your cross product operation. Okay, so after you do the cross product operation, the answer here you need to dot product with the unit vector. Because this is the component for k, you do the dot product for the component of k, and then your unit vector here also is a component of k. So if you still remember, if you want to perform the operation of dot product, you need to multiply each component with their respective component, like I with I, j with k, and k with k. Like in this case, so because this is the k component and it is a k component, so simply you can multiply to each other, and then the answer is 15.5. You also can do the cross product operation for other component like I component. So you eliminate this line, so you do the cross operation here, and then for j component the same thing. Okay, so you do the cross operation for this one. But the thing is, after you do the cross operation, when you do the dot operation, it will multiply with 0 for each component I and k. So the equation, you will get 0, for it is left only k give the value. So that's why we only do the operation of cross product for k component. Okay, so this one. And then one more thing, maybe I should draw the line of action here to make it clear. So this is your line of action R. So this is your line of action, and then this is your F, and then your moment should be in this direction. Okay. Yeah. So this moment, the value of this moment you can simply get from this value of cross product, and then to get the moment for this one, the moment about an axis of z, so you need to do the operation of dot product between the unit vector of this axis with this and with this moment. Okay, so like this one. Okay, that's it.